Okay, here we go with 2f rational functions. There's just so much going on in this section that I did not put a stop box in because there's just so much going on. You could always do one for yourself if you wanted to just like summarize or put like what you think is going to be the most challenging piece in it. But I just really wanted to focus on what all these notes were for today. So rational functions are definitely something that we've seen so far in this class, and we have seen it. You should have seen it like last year, but we're going to take today to really focus on those rational functions. So when we think about rational functions, we think ratio. So a rational function is when a linear function is divided by another linear function. So it definitely has that division. So all that stuff where we've been looking at, oh, we can't divide by 0, and we've been looking at finding those asymptotes and finding where that function is undefined, those ones were rational functions. We're going to use some of those skills today. In a general form, it looks like this: ax plus b over cx plus d. That's kind of the most general form you might see. You might see ones that are even more simple in the sense that you might have like no x in the numerator. If you have no x on top, that one's like a little bit less going on. You might see some that are more complex and have something added to this fraction. And we will talk more about that in a little bit. But what happens when we have this rational function is it creates those asymptotes. The lines of the function gets closer and closer to, but never quite reaches. So we already talked about in class how we can't divide by 0, so we get a vertical asymptote at whatever value would make that function undefined. But we'll also take a look at horizontal asymptotes, which could be challenging as well. We're first just going to kind of look at asymptotes just to make sure we do remember what those asymptotes are, and then we'll get into the examples. And so for these types of problems, your assignment is actually kind of short because there's a lot to it. We're going to get one problem and do 5 different things with that one problem. And so there's not a whole lot on your assignment, so we can focus on that. Just remember that those asymptotes can be vertical and horizontal. So in this graph right here, we've got a vertical asymptote at x equals 0. And then we also have a horizontal asymptote at y equals 0. So it's just a nice reminder that if you've got a vertical line, it's just x equals. If you've got a horizontal line, it's just y equals whatever that number is. Are we all good? Like, we get what asymptotes are? Okay. So this function, f of x equals 2 plus 3 over x plus 2, we are going to do all of our examples with this same function. The first thing we will do is determine the equations of the asymptotes. We'll use that to state the domain and range. After we do those things, we'll be able to find intercepts, which is something we've done in class already. Then we're going to graph it, and then we're going to get to like the kind of really you have to think a lot about piece. Now, before we actually do this, I want to kind of take a step and zoom in on my little piece here that kind of explains how do you find the asymptotes. Vertical we've already been doing, but horizontal is something new, so we're going to take a look at that. So the vertical asymptotes, this is where that function is undefined. Remember, you can't divide by 0. So every time when we looked at finding the domain and even when we looked at finding the undefined pieces yesterday with our sign diagrams, remember that that's where you take like the denominator, you take what you divide by, and you set it equal to 0 to find that asymptote because you can't divide by 0. So vertical asymptotes, we actually have been doing that so far this chapter. The horizontal asymptotes are where things can get a little bit complicated. So to find out where the horizontal asymptote is, we need to take the ratio of the coefficients on the x terms. So if I have a general function like this, ax plus b equals cx plus d, I'm looking at the coefficients on the x terms, a over c. So sometimes that'll be like a nice number like 2 or whatever, but sometimes, it might be at like a fraction. But whatever this ratio is, that's where our horizontal asymptote will be. That's kind of like the most basic one. There's one that's a little more complicated, and there's actually one that's a little less complicated that we will also talk about. But that's kind of where we start. Now, if there is a constant term added or subtracted to our rational function or our algebraic fraction, then we add or subtract it from that ratio. That's the asymptote. So let's say I have something like this, the ax plus b over the cx plus d, but I'm adding a number to it. If I'm adding a number to it, I take the ratio and then I add that to it. So my horizontal asymptote will be that ratio plus f, whatever that is. So that's kind of like the more complicated one where you have two different pieces if you are adding to it. I do have another little thing I want to zoom in on. It's actually when finding the horizontal asymptote is a little bit less work, kind of a little shortcut for certain types of problems that we'll take a look at next. So then, kind of a shortcut is, let's say you just have a number on top. If you have no x on top, but you've got something added, then it's just going to be whatever is added. And let's think about it this way. We don't have an x, so that's like, what, 0 over c? Well, I would do this, right? I would take the ratio plus f. Well, what's 0 divided by anything? 0. So it's just f. So you might have some problems that there's like a shortcut. If there's no x on top, it's just going to be that f, or it might just be 0 then. So like even if we didn't have this, there's no x on top, then that asymptote is just 0. But you can still, if you feel more comfortable not using a shortcut, you can still use the ratio plus whatever is added or subtracted. Now I know this is kind of funky. You're going to have a couple on your assignment to take a look at. What we're going to do now is go back to that problem and do all those different things. So starting with the asymptotes, let's go ahead and start with the vertical asymptote because that's what we're most familiar with. So remember, the vertical asymptote is when your function is undefined. So that means that I know that x plus 2 cannot equal 0. So I have to find, okay, where is that one place where it does equal 0? So So if x plus 2 equals 0, then what is x? Negative 2. So that's our vertical asymptote. That means we're going to have a line going up and down at negative 2 where our function's not going to cross. So like I said, I know we've been doing that because we've been working with domain and the sign diagrams and all that. Any questions there? So then for our horizontal asymptote, you might notice that this is one of those kind of shortcut problems where I don't have an x, so I can go ahead and say it's 2. But if we don't want to, okay, what's the coefficient on x right here? Like, what's the number in front of x? 1. Okay, well, there's no x up here, so I'd have 0 over 1 plus 2. Well, what's 0 divided by 1? 0. So it's just 2. So I did not use the shortcut there, just to kind of remind you guys that full way to do it. But what that means then is that at y equals 2, that is where we will not have our function crossing. Our function will not cross that horizontal line at y equals 2. Now we're going to use these things to graph our function coming up in a couple of steps here. So make sure that you've got this really clear on your notes so you can come back to it. Now the domain and range will go directly to this problem here. So the domain are all the x's except where the function is undefined. So my domain are x such that x just cannot be negative 2. That's the one thing I can't put in. So notice how the vertical asymptote and our domain are related. Now earlier this week when we had to do range on something like this, I just told you to graph it and take a look. Well, I can do the range myself now because I know that I will not have a y at 2 because that's where my horizontal asymptote is. Any questions here? The next thing we're going to do is find the intercepts. And so after we find the intercepts, we'll take that information, we'll take the asymptote information, and then we will graph it ourselves without using technology. So, like I said, we're going to find the axis intercepts. So we're going to have to find the x-intercept and the y-intercept. Now, finding the x-intercepts, we actually did yesterday. We just didn't call it that. The x-intercepts are the zeros. So that means that our function f of x we set equal to 0. So to find the x-intercepts, to find the zeros, we set our function equal to 0. Remember, f of x is like y. When we cross the x-axis, y equals 0. So I've got 0 equals 2 plus 3 over x plus 2. And so at this point, you want to use your solving equation strategies to get x by itself. So I would recommend subtracting the 2 over. So we have negative 2 equals 3 over x plus 2. Now, do you guys have any suggestions for solving? Yeah, absolutely. So we can multiply by x plus 2. If that freaks you out, don't forget you can always do that when you put that as a fraction. What does this make you think of? Yeah, cross multiplication. So that absolutely works, but I feel like a lot of my students feel very comfortable with cross multiplication, so that's why I suggest it. So I end up with negative 2 times the x plus 2 equals 3 times 1 is 3. Now this is a linear equation, so this shouldn't be too bad to finish off. Negative 2x minus 4 equals 3. negative 2x equals 7. And I know I'm about to graph this, and personally, even though I hesitate to say I'm a fan of fractions, I'm afraid of exact numbers, but it's easier for me to graph when I have a decimal. So I'm going to go ahead and write this number as a decimal, negative 3.5. So when we graph this, we'll put a little dot at negative 3.5 because that's where we will cross the x-axis. So then our y-intercepts, remember to do our y-intercepts, that's when x equals 0. So we'll go ahead and put 0 in for x. And then we want to simplify that. I'm going to go ahead and switch this one into a decimal again because I know I'm going to be graphing. So that's 1.5. And it equals 3.5. And I'm going to go ahead and switch my f of x or f of 0 just to y because I know that's the y-intercept and that's what we're going to be marking on the y-axis. Now, I know we've done these types of things before, but are there any questions about any piece of that? Now, the way it's listed in your text, I'm kind of doing out of order. They say like part 1, asymptotes, part 2, domain and range, part 3, axes, intercepts. Then they do this really hard thing we didn't get to for part 4, and then they say graph last, and I disagree. I think you should do it out of order. You should graph, do part 5, and then go back to part 4 when you get to your assignments. So that's exactly what we're going to do is we're going to take that information and we're going to graph it because in my opinion, you really need the graph before you can answer those other questions that we're about to get to. So make sure that you give yourself enough space to graph so that you can see this. And it's a sketch, so I'm not gonna take a ruler out and take a look at how accurate you are on it. Give yourself just an x and y coordinate plane, and the first thing you should do is sketching your asymptotes. So who can tell me where the vertical asymptote was? -2. So I'm gonna approximate where, I don't know, on my graph -2 is. I'm gonna draw a dotted vertical line. X equals -2. All right, where's the horizontal asymptote? At 2. So again, I'll kind of estimate where that is on my graph, and I'll say y equals 2. Then we're just going to mark where our intercepts are. So where was my x-intercept? -3.5, so that's about here. And if I recall, my y-intercept was +3.5, coincidentally. So everything we've done so far, besides the domain, I guess, we've put onto our graph. Now, remember that we get really close to the asymptotes, but we don't touch them. So I'm just going to draw some curves that go through my axes, but don't touch the intercept, or I'm sorry, don't touch the asymptotes. So I'm going to come down, make sure I go through there, and then, so mine got a little bit out of hand, a little crazy, but you guys kind of see it doesn't have to be perfect. We're just drawing that curve. We're getting close to the asymptotes. We don't touch them. We do go through the intercept. And I did the same thing again where I didn't really give myself a lot of space here, but I'm going to come in, go through, and then just get really close there. Now, the last part, I think, is the trickiest part because we probably have never asked you guys to think about functions in this way before, and it's kind of a preview to some things that I know you do in calculus, so if you're going to take calculus or SL2 next year, you get like a little start to it here. We need our graph, and again, I really feel strongly we need our graph to do this, so everyone's got the graph on their paper. And I ended up using a graph out of decimals so that I could write on it a little bit more easily, so I do have a graph that we're going to look at. But before we get to it, this is just a little notation thing. So we're going to talk about our graph coming from different directions, coming from the right, your right, from the left, from above, and from below. So if we're coming from the right, that's an x, and I want to make sure I get this notation the way I want it to be. To note from the right, we're going to put a little plus sign after our number. So in this particular problem, what's the x asymptote? What are the x's getting close to in this problem? Or not the x asymptote, the vertical asymptote. -2. So we're going to have -2 from the right. And then if I'm talking about from the left, I put a little minus after it. So this will make more sense in a second. Jot these down. Just keep in mind that from the right, we'll have a little plus after it. From the left, we'll have a little plus, left will have a minus after it. These numbers change depending on your asymptotes. From above, well, what was that horizontal asymptote that the y's are getting close to? 2. So if I'm coming from above, I have a little plus sign after it. And if I'm coming from below, I have a little minus sign after it. So keep in mind the 2's and the -2's change for whatever problem you're working on. I just use these ones to go with the example, but we needed to talk about from above we'll have a plus sign and below we'll have a minus. From the right we'll have a plus and the left we'll have a minus. And the weird thing is it comes after the number. And now we'll get to it and actually do what we're going to do. And so here's mine that I graphed. The question says, discuss the behaviors as the function approaches the asymptotes. And I know the word discuss generally means you're going to write a few sentences. That's not what we're going to do here. We're going to use symbols to kind of discuss what's happening with our function. I'm going to sketch in the asymptotes just to make it easier, and we'll just start with the x asymptote first. So if I start with x, as it approaches -2 from the left, just write that down. Write that down, and we'll get through it. Like I said, I know it's weird. We've never really thought about it like this before. But so here are my x's. My x's are coming in from the right. What's happening to my y's? As my x's are coming in from the right, what's happening to the y's? They're going up, right? Do you guys agree? Like my y's are getting bigger and bigger? What's the biggest number you can tell me? Kind of a trick question, but the biggest number. Think Buzz Lightyear. Infinity, right? That's the biggest number. So what happens is that as my x's are going like this, my x's are getting closer and closer and closer to -2. The y's just get bigger and bigger and bigger. They go to infinity. And so I suppose you could write a sentence that says, as x's approach -2 from the right, then y approaches infinity. But aren't these symbols nice? Kind of getting used to them? Okay. But we also have to talk about x approaching -2 from the left. So remember that little minus sign after it means from the left. So that means I'm going this way, and I'm getting really close to -2. But what's happening to my y's as I get really close to -2? They're going down. What's the smallest number you could say? Any guesses? Absolutely. So y is going to -infinity. So what we do is we still have 2 more pieces to this. But we look, okay, as x's are going towards the asymptote from each side. As x's are going towards the asymptote, what's happening to the y's? The next thing we have to look at is what about x is going away? Like if I'm going like this, where are my x's headed towards? So I'm going this way and I keep going and going and going. Are my x's getting bigger or smaller as I go this way? Bigger, because I'm going like 2, 4, 6. So we already talked about what's that biggest number we could write down? Infinity. So as x approaches infinity, so x's are getting bigger and bigger and bigger, what's happening to the y's? What are the y's getting really, really, really close to as I keep going out? That asymptote here, that was y equals 2. So we will say the y's are approaching 2, but we just want to note that we are coming from the top. So since we're coming from above, we'll write that little plus sign. The last thing we have to discuss is what happens when my x's are going this way. Where are they headed? Negative infinity. So as my x's are headed towards negative infinity, the y's are getting really, really close to what? Yeah, that was kind of weird, huh? And we'll put the little minus because that's actually coming from below. So that just lets us know that these ones are coming from below and those ones are coming from above. So like these ones might be like 1.99999, but here this might be 2.1, you know, like kind of lets them know those numbers. So I know that that is a lot. So you only have 2 problems to do on your assignment that are like this. Actually, I was looking at the assignment and I was like, man, I wish I made it longer. So you guys got lucky. I'll have to talk to Ms. Friends about making it longer next year. So 1A and 1B are those 2 problems like that. So 1A, you'll have a function, you have to go through all those steps. 1B, you'll have a function, you have to go through all those steps. Number 2 is one of those really thinking problems. So don't get frustrated if you don't get number 2 right away. Come in with a question, right? Because number 2 is not like a normal problem. It's like think about it. So give yourself a chance. And then I just want you guys to get a little bit more acquainted with these types of functions. So I do want you to also do investigation 2 and 3, which is on page 70 and 71. Now, about that investigation, I did put it on Google Classroom this morning, but I want you guys to take a look at it, so I want to make sure everyone has a chance to write this down first. All right, did everyone get it? Not quite? So oh, I got signed out, sorry. Let me sign back in here. Okay, so I put it in here just like I did last time, but note that what it says here. So use technology to complete the investigations. You may choose to do these on paper and check in class or via the attached Google document. So if you want to type them in like last time, you can go in here and type them in. I mean, it's right out of your textbook. But if you want to just write the answers down as part of your assignment and just check it in class, I'm fine with that too. So does that make sense how you got the option, whichever way like makes sense for you? So keep that in mind. Are there any 2E questions we want to go over from yesterday's